Okay, 10.4 day 1 homework calc. I'm going to take a look at 3 problems. Going to take a look at one where they ask us to find the center, vertices, foci, and the equations of the asymptotes of this hyperbola, and then ask us to sketch the graph. Second one, basically same problem, find the center, vertices, foci, and equations of the asymptotes of. This time they give us another hyperbola, that should be a plus sign, another hyperbola, and then ask us to sketch its graph. And of course the big thing with this one is it's not in standard form. And then the last one I'll do is ask us to find the standard form of a hyperbola where they give us random information. The particular information they give us here are vertices and then the asymptotes of the hyperbola. Alright, so I think what I'm going to do is I'm going to do the graph part of it first, and then we'll come back and we'll find all the information. Typically these are like, I treat them as if they're 2 separate problems. Drawing the sketch, you don't necessarily need to list out all of this information. You find a lot of it, but you don't need to list it. Like for example, the foci aren't important for drawing the sketch. Finding the equations of the asymptotes, not necessarily important. I will draw the asymptotes, I will come up with points, but I don't necessarily need those specific things. So okay, to start with, I'm going to give myself a graph here, so let's do that. Alright, and I'm going to be going by 2's, if that's okay with you. I'm going to be going by 2's. And I'm going to do that because I recognize that my denominator, when I take the square root of that, is going to give me 12. So I'm going to have to move quite a distance. Alright, to start with, my center is, and you don't have to list it out, I'm listing it out because eventually I'm going to have to find it anyway, and this is very quick and easy to find, is going to be -3 and then +2. So at -3, remember I'm going by 2's, so -3, +2 would be right here. Again, I put an X, you can put a dot, you can put really whatever you want. Alright, that's my center. Now, to find the rest of my information, regardless of whether they're vertices or other points or whatever they are, you do the same thing that you did to graph an ellipse, almost. You're going to take the square root of this denominator. You could care less whether it's a squared or b squared. It's a squared if you remember. For a hyperbola, the positive term, that denominator is a squared regardless whether it's bigger or not. So a in this term is 12. Like I said, I don't care that it's a. The square root of this is 12. Notice that it's under x. So from here, I'm going to move to the right 12. So 2, 4, 6, 8, 12. There's 1 point. And then to the left, 2, 4, 6, 8, 12, there's another point. Just like you would if you were drawing an ellipse. You're going to take the square root of this number. Again, you don't care if it's a or b right now. Look at the fact that it's underneath y, so you're going to go up and down 5. So you're going to go down 2, 4, 5 right there. And then go up 2, 4, 5 right there. Remember, again, I'm going by 2's. Now, you would look back here. If this was a plus sign, you would simply draw your ellipse and you'd be done. Since it's not, since this is a hyperbola, what you're going to do instead is this. You're going to draw horizontal and vertical lines through these points to give yourself a rectangle. And I ask that you draw this in very lightly because this is really not part of your graph. This is just going to help us get the graph. You can probably tell if you weren't sure, but there are asymptotes in this thing. And you can tell because they said that there were asymptotes. Well, the asymptotes, how you get them is you go from corner to corner of this rectangle. So if I drew a straight line from corner to corner of that rectangle, that would be an asymptote. So because asymptotes are normally dashed, we're going to go ahead and draw this dashed the best that we can. So there's one asymptote. Here's another one. And so that's the reason that we draw that rectangle, is it helps us find those asymptotes accurately. The last thing I'm going to do is finally sketch the equation of this graph. Now, these 4 points that you see listed here, 2 of these are vertices. It's either these 2 or these 2. If it's these 2, then the hyperbola would open up and down, and they'd be really wide because the asymptote here is kind of shaping it to be really wide. If it's these 2, then they would be opening right and left, and they would be a little bit narrow. The asymptotes kind of shape it. Well, how do I tell whether it's up and down or right and left? Look back at your equation and look at the positive term. Right? This one's implied to have a plus sign in front of it. This one's got a negative sign in front of it, so that's the negative term. The positive term has x in it. What direction does x go? It goes right and left. So these are actually the vertices. And I simply use the asymptotes to kind of shape my, you can almost call them little parabolas if you will, to shape my hyperbola. And that's what the graph would look like. So realistically the graph is just those two curves. All that other stuff is just kind of used to help me get that to be fairly accurate. So it is important because these things are your vertices. These would be considered those, remember they don't call them anything, or we call them the other vertices. Alright, so there's the graph. Again, very similar to what you would do for an ellipse. You find the center, you go right and left a certain distance, up and down a certain distance. Instead of drawing the oval, you draw a rectangle, corner to corner to get the asymptotes, and then look back at the equation to figure out if it's right and left or up or down or not. Alright, to list everything out, we already listed off the center. Let's go back and find the vertices. Now the vertices, when I pretend like I don't actually have the graph sitting here, the positive term is going to help you figure out the vertices. This is the positive term. It's x. So I should be moving right and left from the center, whatever the square root of that number is, so 12. So the vertices, that's a little bit different with the ellipse. Ellipse, the positive term is always the a squared term is always the biggest term. That doesn't have to be the case here. It's always the positive term. So I'm moving 12 to the right, which would give me 9, 2, and 12 to the left, which would give me negative 15, 2, which if you had tick marks and we labeled everything, that's what those 2 points are. So there are the vertices. The foci, I didn't actually find the foci. The foci would be somewhere here and here. The equation for the foci, and be very careful with this because it's tricky, it's c squared is equal to a squared plus b squared. For the ellipse, it was a squared minus b squared. For a hyperbola, it's a squared plus b squared. So you got to be very, very careful. Well, there's a squared and there's b squared. So c squared is equal to 144 plus 25, or c squared is eventually going to give me 169, and if I take the square root of that, I get plus or minus 13. And they need to move the same direction that the vertices do. Remember, we called this the transverse axis. Not overly important. You just need to know that they're going to travel the same direction. So if the vertices move right and left from the center, the foci will also move right and left from the center. So my foci moving 13 to the right, adding 13 would give me 10, 2. And then subtracting 13 would give me negative 16, 2. There are my foci. And now the equations of the asymptotes. Well, if I go back and I look at my graph, I know the center is right here. It just so happens that both of those asymptotes go through it. I could easily figure out what this point is. I mean, I know how far to the right I moved. I moved to the right 12. I know how far I moved up. I moved 5. So from that point, if I added 12 to the x value, 5 to the y value, I could figure out this point and then find the equation of the asymptotes. Well, there's an easier way. We said that I moved to the right 12. We said that I moved up 5. That's the slope. Slope is rise over run. The slope of this line is 5/12. And you can see it from looking at the equation. I'm going to write the equation down here again because that's getting a little bit messy. But you can see it by looking at the equation. You have to be a little careful because it can be tricky when you start moving some information around. But overall, you can always see it just looking at the equation. So how do I know the slope is 5/12? Well, remember what we said. Slope is rise over run. It's always the y value divided by the x value. There's y, take the square root of it, divide it by, there's x, take the square root of it. So my slope will always be, well, for this one, 5/12. It's always rise over run. So square root of whatever's under y divided by square root of whatever's under x. So if y was over here, it would be that over that instead. So the equation for this one, because that looks like it's positive, is going to be y is equal to 5/12 x plus b. And then I can plug in the center would be the one that I would plug in since it's the same. And then for the other one, it would be y is equal to negative 5/12 x plus b. And all I have to do is plug in the center to both of those, and it'll give me the equation. They're most likely going to have a different y-intercept. Now that's the way we did it in class. You're going to find out that what we do tomorrow is something a little bit different. You can do whichever one you like better. It'll always be this equation when you're looking for equations of the asymptotes. It's y is equal to, it's going to be k plus or minus, I'm just going to write slope here, and then times x minus h. So think about what k is. K is the y value of the center. So the y value of this center is 2, plus or minus the slope is 5/12. Well, notice it's plus and it's minus, so it's 5/12. Now when you look at the equation that we do tomorrow, you're going to see they put something different there, but I'll show you what I mean by why I just say slope. It's always y over x, the y value over the x value, just remember that. And then x minus h, that's actually that parenthesis, whatever has x in it, it's x plus 3. And that is actually both of those. If you actually multiplied out positive 5/12 simplified, multiplied out negative 5/12 simplified, it would give you those two. That's why the book is always giving answers that looks like this, and that is fine. If you like this method, go for it. If you like that method, go for it. This is what we'll look at tomorrow, though. Alright, same problem, just a little bit different information. Of course, the first thing you should look at is see this and say, well, it's definitely not in standard form. I don't see any parentheses squared. It doesn't equal 1, and so on. Identifying that it actually is a hyperbola, squared term, one of them is negative. Now I know it's a hyperbola. And then do I need to complete the square? It sure looks like I have to complete the square with the y's. I've got a y squared and a y. I don't have to with the x's. I've got an x squared, but there's no regular x. So that's kind of nice. I can leave x squared all by itself. When I put the y squareds together, I will have to complete the square with them, and then I'm going to move the 72 over to the other side. So completing the square, remember I want the 9 to be, I don't want the negative 9 to be there basically, I want it to be 1, so I'm going to factor out negative 9, which gives me 1y squared minus 4y. And then I can take half of the b value, square it, add it to both sides. Technically I'm adding it inside parentheses, so be careful. Half of that gives me negative 2, squaring that gives me 4. And now I'm not actually adding 4, I'm actually subtracting 36. And so now, completing the square, I have x squared minus 9 times the quantity y minus 2 squared is equal to 36. 72 minus 36. Alright, and then last thing, I want this to equal 1, so I divide everything by 36. And that gives me x squared over 36 minus, that would simplify to 1/4, so it's y minus 2 quantity squared over 4 equals 1. And now I've got it in standard form. And like I said, realistically, that's the heart of this problem. If you can get there, then you're basically just doing this again. So we'll go through and do that again just so you can see it. This time I'm going to find all the information first, and then if I've got room, I'll go ahead and graph it. So looking for all that random information. Now that I've got this equation, let's start with the center. Center should be the easiest thing to find if it's in standard form. It's going to be 0, 2. Alright, let's look for the vertices. Now remember, it's going to open depending on which, it's going to open a specific direction, up or down, left or right, depending on which one's positive. For this one, there's the positive term, it's x, so it's opening right and left. My graph would look something like that, which means the vertices are moving right and left from that x value. So they're moving right and left from the 0. So what number, how far are they moving? Looks like they're moving 6. So the vertices, if I move 6 to the left, would be negative 6, 2, and then if I move 6 to the right, would be positive 6, 2. Alright, the foci. I need the c squared is equal to a squared plus b squared. There's a squared, there's b squared. So c squared is going to equal 36 plus 4, or 40. Take the square root of both sides, you're going to end up with 4 times 10, so 2 square roots of 10, plus or minus. Again, foci go the same direction that the vertices do, so I should be adding and subtracting that from x. So it should be 2 square roots of 10, comma 2, and negative 2 square roots of 10, comma 2. There are my foci. Equations of the asymptotes. Remember how I did that? It was slope. So I'm going to do the both ways again so you can kind of figure out which one you like. But it's y is equal to the slope. There's y, so it's this denominator divided by this one. It's not actually those numbers. Those are a squared and b squared. I want the b's and a's. It's actually 2 over 6, or 1/3. So I'll do one here where it's 1/3 x plus b, and another where it's negative 1/3 x plus b. And then to figure out b, you are going to plug in the center in for x and then solve. Plug the center in for x and then solve. Or, if you like kind of that little shortcut thing, it's y is equal to the y value of the center, plus or minus the slope, which we said was 1/3, and then the x parenthesis, which would have been x minus 0. And there it is, kind of a quicker method. Alright, so there's finding all the random information. In terms of the graph, let's go ahead and grab an extra sheet of paper here. In terms of graphing it, if I want to graph it, give yourself an XY axis. Since I'm moving 6 and 2, I should be able to just go by one tick mark. 6, 7, 8, 9, 1, 2, 3. Alright, and we'll start with the center. Center looks like it's at 0, 2. I guess since we found all this information, I could just graph it that way, but I don't like doing that. I like being able to look at the equation and kind of figure it out from there. Square root of 36 is 6. It's under x, so go to the right 1, 2, 3, 4, 5, 6. Go to the left 1, 2, 3, 4, 5, 6. And then square root of 4 is 2. Go up 2, 1, 2. Down 2. Lightly draw in that rectangle. And then from corner to corner, this is going to be your asymptote. There's one of them. Here's the other one. And then looking back at this equation, it's the positive term is right here. It's x that's the positive term, so this should be going right and left. And make sure that you're using these vertices as kind of your vertex points for those parabolas. Alright, the last one that we have is, given some random information, can I find the equation of the hyperbola? So, I noticed they gave me the vertices. Again, I'm going to start with setting it up. Now, notice what's changing. It is x that's changing. So when I write this, because it's x that's changing, that means the a squared should be under x, and that's the positive term. So it's going to be x minus, what's the center of that? It's 0. It's x minus 0, so I could just say x squared minus y minus 0, or I could just say y squared is equal to 1. Now, we said the center was 0, 0. What's the distance between either of those vertices in the center? It's 1. Well, that distance between a vertex point and a center is a. I know a is 1. 1 squared is still 1. So I know that 1 should go under the x term. The only thing I'm missing is b squared. Now I got all that information just with this, so apparently I'm probably going to be using the asymptotes. Remember what we've always said. To find the slope, it's the square root of what's under y divided by the square root of what's under x. So the slope for my asymptotes, without them actually telling me, should equal over here. It's the square root of b squared, which is b, divided by the square root of 1. They are telling us that it's equal to plus or minus 5, or basically 5 over 1. And then what you would do is cross multiply and solve. Obviously, since the denominators are both 1, I know that b is equal to 5. So my final answer would be x squared over 1, I don't need to say that, minus y squared over, since b is 5, b squared would be 25. And then it equals 1. And that would be my answer. If by chance they had told you that the slope was 5/3, then you would cross multiply and try to solve from there. Alright, that is homework help for 10.4 day 1.